So in this video, we're going to summarize our module on form. What we find is that very often, almost always, the product system we build has to be joined by other what we call accompanying systems in order to deliver value. The most common of these is a power supply that's necessary in order to power our system, or a structural support that literally is just necessary to hold our system up and together. There are many other types of accompanying systems, including an operator. Collectively, we call the product system and the accompanying systems the whole product system, because all of the parts have to be together, working, interacting in order to deliver value to the customer.
To me, whole product system really refers to designing something for the life cycle of the system. So not just what the product is, also how it's going to be used, how it's going to be produced, how are you going to market it, how are you going to sell it, and then also some thought on the life cycle. How is it going to be disposed of? Are you going to recycle it? Are you going to just throw it away? So putting that thought in place early on is part of what makes the system viable over its entire life cycle.
There are, of course, formal relationships. There's structure that exists between the accompanying systems and the product system. There's connections in some cases, and there's spatial relationships in some cases that have to be understood. It's good practice to take the product system and draw around it a dashed line representing the boundary of the system that we're responsible for. This aids us in several ways. It helps define what's in and out of the system. It helps you as the architect understand what you're actually responsible for delivering, and it helps us understand what is fixed or constrained at the boundaries. Every place one of these structural relationships crosses the product system boundary, there's the necessity for an interface. This is where our system has to interact with the accompanying systems.
One example I can bring up here on the Commercial Crew Transportation System program. This is our commercial transport to bring astronauts, crew, and cargo from the ground up to the International Space Station. One of the things we looked at is, did we want to include the launch vehicle, the rocket, as part of our system or not? We envisioned this as kind of a taxi. The astronauts would drive up, load their stuff in the trunk, climb in, and we launch them up to station. As part of that vision, then we would want to have control of the rocket. It means we're responsible for the design of it as well. This way we can now decide where it makes sense to put things, whether on one side of the interface or the other. If you take the flip side of that, we're no longer responsible for the rocket. Yay, we don't have to do that design work, but we no longer have control over that interface either. We have to negotiate where things go, and someone else gets to make the final decisions.
And as we know from system engineering, interface definition and interface control is a really important part of making a system work well. So let's apply this thinking about the whole product system and accompanying systems to our examples of the bridge and the aircraft instruction card. If we look at the bridge and we ask, if we were the architect of the bridge, what are the accompanying systems that need to be present and working effectively in order for our bridge to deliver value? There are clearly two at least. One is the roadways that lead up to the bridge on each side, where there's an interface between the roadway and our bridge road surface, but it would be the connection between the bottoms of the towers and the bedrock or other earth in which the towers are supported. And there the interface is one of structural support. If we look on the other hand at our aircraft instruction card, we see again there are two other important accompanying systems. On one hand, there needs to be a source of light to illuminate the card, and on the other hand, there needs to be an operator, a person with vision who's able to read the card and understand the images on the card. And in this case, the interface, in both the case of the ambient light and the reflected light, is actually the surface of the card. That provides the interface between the printed matter and the reflected and ambient light. So let's summarize and review what we've learned about the form of systems. The first step is to define the product system. What is it that we're going to build? And we'll use the operational amplifier circuit here again as an example. Then we ask the question, what other accompanying systems need to be present in order for our system to deliver value? For the op amp, it's clearly the input circuit that produces the lower level voltage, the output circuit, which needs a larger level of voltage, higher level voltage, the power supply, and the ground. Then we can decompose our product system and draw the red rectangle, the product system boundary. We can fill in the structure of the system, both connectivity and spatial relationships if necessary. And finally, we can identify the interfaces between our product system and the surrounding systems, the accompanying systems. The form we build and deliver we'll call the product system. And in order to deliver value, the product system must be joined by accompanying systems. And there are important interfaces between the product systems and the accompanying systems where connections and spatial relationships cross the product system boundary, and these need to be controlled by interfaces.